All right, so here's the video for lesson number 10, seeing structure and what we're calling advanced factoring. So essentially, we're looking for the same structures that we're used to seeing in other problems, but these are just going to look slightly different. Like they might have different exponents, you might have different bases that you're raising to exponents. So we're going to go through a couple of these just so we can kind of see how they are really the same, just with little twists and differences. So let's look at the first one. So for the first one, we see y to the fourth minus 21, y squared minus 100. So that looks very similar to just something like x squared minus 21x minus 100. So I'm going to factor it the same way. So I'm going to start by making two parentheses. The first part of each parenthesis is going to be y squared. I know that because y squared times y squared makes y to the fourth. Now what I'm doing is I'm asking myself, what multiplies to make negative 100 but adds to make negative 21? So that's going to become negative 25 and positive 4. Then we always have to ask ourselves that same question, can I still factor? And the answer is yes to one of these binomials, no to the other. So y squared minus 25 is totally factorable. That becomes y plus 5 and y minus 5. Y squared plus 4, because it's a sum, there's no such thing as difference of two sums. That doesn't make sense. It's difference of two squares. So this is the only thing that we can do, and we're done. For the next one, we have four terms, so that tells me grouping. So I'm going to look to group. So we have n to the fourth, leaving us with n squared minus 1. Negative 16, leaving me with n squared minus 1. What we're looking for there, remember, is for the two parentheses to match, which they do. Lucky us, and we can keep going. So I know that n squared minus 1 is my GCF, leaving me with n to the fourth minus 16. Both of which are factorable. So this becomes n plus 1, n minus 1. This is going to become n squared plus 4 and n squared minus 4. There's a trick there because I can still factor that again. So the n plus 1 doesn't change. The n minus 1 doesn't change. The n squared plus 4 doesn't change because it's a sum. But the n squared minus 4 becomes n plus 2, n minus 2. So essentially we're just going to keep factoring until there's nothing left to do. All right. Number 3 is similar to two questions that we did in class where we have this expression in the place that we're used to just seeing something like x. So we're going to replace it. So I'm going to make this u equals 2x squared minus 7x. And I'm going to replace that 2x squared minus 7x with the variable u to make it easier for me to factor. So I can go through then and factor that. It's going to become u minus 4 and u plus 3. What multiplies to make negative 12, but adds to make 1. All right, so now that I have this factored, I can replace the u's with 2x squared minus 7x. So this is going to become 2x squared minus 7x minus 4 and 2x squared minus 7x plus 3. Notice both of those expressions have a coefficient greater than 1, so we're going to use the AC method. So I'm going to multiply the first and last numbers together. That gives me something that I can use then to figure out what the two middle terms need to split to. So for this first one, I'm going to rewrite this as 2x squared. What multiplies to make negative 8 but adds to make negative 7 is negative 8x plus 1x minus 4. I have 2x to the second power. And what multiplies to make positive 6 but adds to make negative 7 is minus 6x minus x plus 3. Now I have to do my grouping. So if I go through and do some grouping here and here, the GCF of the first two terms is 2x, leaving me with x minus 4. I have x minus 4 already, so it's going to be plus 1, x minus 4. So that first parenthesis is going to factor completely to x minus 4, 2x plus 1. Second parenthesis has a GCF of 2x. So that would become x minus 3. Notice how this is negative x plus 3, so that tells me to take out negative 1. That'll change to x minus 3. So now I have x minus 3 and 2x minus 1. Nothing left to factor, so that's done. All right, let's look at the last one, number 4. So to factor that, I'm going to make the AC method again, negative 8. So I'm going to rewrite this as 8x to the 6th plus 8x to the 3rd minus x to the 3rd minus 1. I know to do that because what multiplies to make negative 8 to make 7 is positive 8 and negative 1. Also, I'm going to use x to the 3rd here because that's the term I'm breaking apart. Right? 8x to the 3rd minus 1x to the 3rd makes back the 7x to the 3rd. If I then do my grouping here, 8x to the 3rd is my common factor, leaving me with x to the 3rd plus 1 minus 1, x to the 3rd plus 1. So now I have x to the 3rd plus 1 times 8x to the 3rd minus 1, both of which can still be factored because we have a sum and a difference of 2 cubes. So x to the 3rd plus 1 becomes x plus 1. Right? What multiplies by itself 3 times to make x cubed is x. What multiplies 3 times to make 1 is 1. The second parenthesis becomes x squared, square the first term. Opposite sign. Multiply the two together. X times 1 is 1x. Last term is always positive, and it's that second term squared. 8x to the 3rd power minus 1, well, that's going to become 2x minus 1, because 2 times 2 times 2 makes 8. 1 times 1 times 1 makes 1. The second parenthesis there is going to be 2x times itself, so that would be 4x squared, plus 2x times 1 is 2x, plus 1. That's my answer. I will tell you 4 is probably the hardest one there because it's involving, 2 new types of factoring in one question. The other ones had older types of factoring that we're used to seeing from Algebra 1. Just remember a couple things about factoring. Number 1, it's not going to go away. So if you're still struggling with this, use the videos. If they're not helping, come and see me. I'm after school on Wednesday. All right, make sure that we don't kind of miss out on this stuff because eventually we're going to need to factor to be able to solve equations, and that's going to be what we're going to do in the next lesson. All right, so just because we're done with learning new factoring doesn't mean we're not going to keep using factoring. You'll use this throughout the rest of the year. All right, so make sure that if you are struggling with this, you come and see me. Hopefully this helps.